in terms of other letters. That the meaning is make t as a subject of the formula. So in view of this, there is something we need to put in place. Let's try to find the xm that we have u is equal to the xm will be vt minus w, because 1 is a fraction on its own. So if 1 is a fraction, so 1 in vt minus w will surely give you vt minus w. So minus vt to divide vt will give you 3v. So something of this. Now we still have to do another meaningful thing, like u it is to divide by 1 also. So to give us opportunity to cross multiply, when we have an equation we can cross multiply. So we have u onto vt minus w is equal to vt minus w minus 3v. So after we have reached this place, we now need to expand to have uvt minus uw is equal to vt minus w minus 3v. So what do we now need to do is that you collect the like terms, especially you group them, those that have t. So we have uvt minus vt is equal to, my vt here is plus before, so it will now change. Recall that the minus here, when it's coming, it will change to plus here. So you have to consider those two factors. Here is minus already. When it turned to this place, this one now came here, it will turn to minus. So the same thing applicable to this, it will move to this place and it will turn to plus. So please take note of that. So therefore we have uw minus w minus 3v. So let's try to make t is common around there. We have uv minus v is equal to uw minus w minus 3v. So let's try to divide both sides by uv minus v. This is also uv minus v. So this we cancel this. So we have our t is equal to uw minus w minus 3v to divide uv minus v. So this is the value of v. And so this is our first example for module 2 of the change of formulae. So let's go to another example. 2. Express k in terms of t, h, and g. So having these questions of this form, like t is equal to 2 pi onto square root of a squared plus k squared over gh bracket close. So the first thing you must do is you square the both side, and in squaring the both side we have something like t square is equal to 2 pi. You start a bracket from here to have the square root of a squared plus k squared over gh. After the bracket we have t squared. So this is how it is. So it is now this square. Remember, when we have a b raised to power 2, you said it is a squared and b squared. So you just put the square. It is not equal to ab squared. No. So it is this that's correct. So we are going to use the same method to solve this. To have t squared is equal to 2 pi all squared to multiply the square root of h squared plus k squared over gh, or in square. So now, in view of this, there's something else you must also consider, that when we have root a, we have to square root a. We used to say 2 we cancel the square root, but some people don't understand it. Square root of a can be written as a raised to power half. So, and a raised to power half, somebody now say you have to square it. So you obey the laws of indices to have 1 over 2 to multiply 2. So it will cancel to give us a. So the same thing applicable to this. We have a t squared is equal to 2 squared pi squared. The same thing applicable to this, to multiply. So these two will cancel the square roots to have a squared plus k squared over gh. So in continuation, which is t squared is equal to 4 pi squared to multiply h squared plus k squared to divide gh. So now, let's try to do something like dividing the both side by 4 pi squared. We have t squared to divide 4 pi squared will be 4 pi squared to multiply a squared plus k squared over gh, or to divide 4 pi squared. So this will cancel this. It will now remain t squared to divide 4 pi squared, which is equal to a squared plus k squared over gh. So we have already have a proper equal fractions. So a over b is equal to c over d. So you can cross multiply from that angle to have t squared to multiply gh, which is equal to 4 pi squared onto h squared plus k squared. So that is the reason, in case you don't know how to for the expansion of brackets, there's I have some of the video you can check from this link. You get how to expand in brackets. Now, what next do we need to do? We are going for k. So let's expand this first. We have a t squared gh is equal to 4 pi square h squared plus 4 pi square k squared. So at this point, let's try to remove the k. We have t squared gh minus 4 pi square h squared is equal to 4 pi squared k squared. So let me try to realize this for you. So we have this is plus already. When it moves like this, it will become minus. So it will remain this only here. So this is plus already. So that is just what I did. So it's plus already. It changed to minus when it's come to this place. So and this one remain here. So that's all. So therefore, now remember when you said A is equal to B, B can also be A. It's part of mathematical equation to have 4 pi square k squared is equal to t squared gh minus 4 pi square h squared. So now let's try to divide both sides by pi square k squared. That is most important thing. So we have k square over 4 pi square over 4 pi squared is equal to t square gh over 4 pi squared minus 4 pi squared h squared over 4 pi squared. So this will cancel this. It will have our k squared will now be this. That is t squared gh to divide 4 pi squared minus this will cancel this over h squared. So what we now to do, we have to find the square root of the both sides. So if you find the square root of the both sides, we have k is equal to the square root of t squared gh to divide 4 pi squared minus h squared. So this is the final answer for this. So I want you to solve this classwork to know how you really understand it. So the first question says that make x as the subject of the formulae, which is r is equal to the square root of ah minus p to divide q plus bx. That is number one. Number two, h as the subject of the formula, s is equal to wd to divide h, whereby open a bracket h minus d over 2. So the last questions for the classwork, r as a subject of the formula, I is equal to e to divide the square root of r squared plus w squared l squared. So I'll be expecting your solution in the group. Please solve it clear, neat, and bold, and use a very good notebook.